Hi, now that we know how to assign oxidation numbers, it's time to look at redox reactions and then separate them into half reactions. Well, first of all, what does redox mean? Well, redox is the combination of the words reduction and oxidation. And I like using the word redox because it reinforces the idea that you cannot have something that is reduced without having something that is oxidized. Just like with acids and bases, the acid always gives its proton to the base. We're going to see in redox reactions that electrons are being transferred. You can't have something oxidized if something is not reduced. So we really need to get these definitions out, and this is something you do have to have memorized. Oxidation is when electrons are lost. All right, so electrons are negative, so when they're lost, the charge is going to be coming more positive. Okay, reduction is when electrons are gained. Well, I know this can be confusing. How am I going to remember this? Well, there are two mnemonics that seem to help chemistry students. The one is oil rig. Oil rig. The O stands for oxidation, and so here's what it is. The oil is oxidation is losing electrons. So that's the way we remember this definition for oxidation. And the rig is reduction is gaining electrons. And remember, electrons are negative, and so therefore it would become more negative. So oil, oxidation, is losing, don't forget electrons, so charges are changing. Reduction is the rig. Reduction is gaining electrons. Another one is Leo the lion goes grr. I like this one a little bit because it has the word electrons in it. So losing electrons is oxidation. That's our Leo. Losing electrons is oxidation. And what do you think the GR stands for? Gaining electrons is reduction. Okay. All right, that's the GR. G-E-R. All right, you got to know those definitions, okay? So what does this look like? How do we know? We've got this equation here. So back at the beginning of the year, we looked at an equation like this. Zinc and nickel 2 nitrate, we've got to practice that naming, yields zinc nitrate plus nickel. We said, hey, this is a single replacement. The zinc comes in, the zinc replaces the nickel, and we just classified this as a single replacement. So don't forget that. That's very true. So the zinc comes in, and the nickel comes out, and the zinc took its place. Single replacement reaction, important to know. Now, why could zinc replace the nickel? Well, it's higher on the activity series, and there in your reference packet is a reference to the metal activity series, and it looks something like this. So, you got all these metals listed in a vertical column here, and the ones higher on the list are able to replace the ones lower. So, if you start up here, it's like lithium's up here, whoopsie, and you see zinc is up there, but nickel's below it, so the zinc can replace the nickel. Okay, well, let's go ahead and have a look at what's going on here. All right, so let's assign oxidation numbers to our metals here in our equation. Zinc here is all by itself, and this is really easy, and just remember, when you have anything all by itself, if it doesn't have a charge up here, it means the charge is L zippo, nothing. Okay, I see something else in this balanced equation where it is 0, and that is our nickel over here is all by itself. And so our oxidation number for nickel is also 0 over here on the product side. All right, now let's look at zinc here. It's combined with nitrate. So it's not all by itself. It's no longer, 0. What is the charge on zinc when it combines with something? If you don't remember, look up nitrate's charge in your polyatomic ions. It's -1. You got 2 of them. It's -2. So the zinc here must be a +2. And maybe you already have memorized that zinc only forms a +2 ion. So when zinc is combined with something, it has a charge of +2. When it's over here by itself, it's 0. So 0 to +2. Did it gain or did it lose electrons? Well, it lost 2 electrons. Remember, electrons are negative. So when you lose them, you become more positive. So we lost electrons, so zinc is, oxidation is losing. Zinc is oxidized. Well, if zinc is oxidized, then something in here's got to be reduced because these are redox reactions. You can't have one without the other. All right, what is nickel's charge here? Well, nickel, we always have to, it's a transition metal who has variable charges. We always have to say a Roman numeral to name its charge when we're naming, so we need to figure out its charge. Nitrate is -1 from our polyatomic ion chart. We got 2 of them. This is -2. Nickel here must be +2. So nickel is going from +2 to 0. So is that a reduction? Boy, I hope it is. +2 to 0, reduction is gaining electrons, and indeed it is. It has gained 2 electrons. So this is how you identify what is being oxidized and what is being reduced. You look at their charges, their oxidation numbers, and see which oxidation number is going up. That's what's oxidized because it has lost electrons. Whose oxidation number is going down? That is reduced because it is gaining electrons. All right, now this is just more vocabulary more than anything else. What is being oxidized? So once you identify what is being oxidized, you say, well, the zinc was oxidized. Let me go back for a minute. Oh yeah, the nickel, I want you to be careful. The nickel, it's not just the nickel metal, it's the nickel +2 ion. Okay, I'm sorry. So whatever is oxidized is called the reducing agent. So once you find out what's oxidized, just say, hey, zinc is oxidized, it is the reducing agent. Whatever is reduced, you say, all right, the nickel +2 ion is reduced, it is the oxidizing agent. Okay, so zinc, we said here it was, zinc was oxidized, so zinc here, it was oxidized, so it is the, you guessed it, reducing agent. And nickel 2+ was reduced, so it is the oxidizing agent. Okay, now we can, I think this even makes it easier, divide it up into what we call a half reaction. Let's just write what's being oxidized and let's just write what is being reduced. So here we go. We started with just plain old zinc as our reactant, and in our product side, it turned into zinc 2+. We don't put this nitrate in here because it's just a spectator ion and we're just looking at what's being oxidized and what's being reduced. We're trying to make this a little more simple. Okay, so here zinc has a 0 charge. Over here it has a +2 charge because it lost 2 electrons. This side of the reaction is +2 plus -2, no charge over here and no charge over here. This is what we call the oxidation half reaction. There we go. I could have put the zinc closer to the arrow. All right, reduction. All right, we started with the nickel, and we ended up with, the nickel +2 is what we started with, and we ended up with nickel here. Which side do the electrons go on? Well, I don't think they go over here because reduction is gaining, and gaining means it's like a reactant. And here now our charge is +2 -2 at 0, and over here at 0. So this is our reduction half reaction. Notice what happens. When we say oxidation is losing, we put the electrons on the product side because they're going away. All right, but then look what happens here. The reduction is gaining, so the electrons are in the reactant side, and so here it is. So it's like the electrons that zinc gives up, the nickel takes. All right, so here's a new reaction. All right, we need to answer these questions. What is being oxidized? Well, what do? Let's assign oxidation numbers. Quickly, what's by itself? Not connected with anything. Has a charge of 0. 0. Good? Okay. All right. Now, I think the copper is changing because it's 0 here and it's combined with something here. Metals are positive. They lose electrons. So from 0 to +2 here. Silver is always +1. It's going from +1 to 0. So what is oxidized? Well, did you say copper? What is reduced? Did you say the silver +1 ion? What is the oxidizing agent? Well, whatever is reduced is the oxidizing agent. And what is the reducing agent? Well, whatever was oxidized. Okay, let's go on. Let's write the half reactions. Okay, well, you can start, let's start with that copper. Copper, and it goes to copper 2+. Where do we put the electrons? Well, the electrons were lost, and we need to balance the charge on this side. This side is +2, side has no charge. It looks like we need 2 negatives here. Okay, that is our oxidation half reaction. Oh, goodness gracious. I'm sorry, we need the reduction half reaction. All right, so then our reduction half reaction is going to be the silver. What is going on, folks? I apologize. Let's see. Oh, I know what happened. Okay, so let's go ahead and let's do the reduction half reaction. Finally. All right, we're starting with 2 silvers, and it's gaining 2 electrons because silver is being reduced and reduction is gaining, which means our electrons are on the reactant side. And there is our reduction half reaction. There's a lot of stuff in this video. We're going to practice this. Thanks for watching.